Okay, we're set up as we're going to be. I think everything is going to be kind of walking improvisation, but
Nice.
yeah.
Cool. So, do you want to get started then? So we'll just say a few things to introduce you.
I can get started. I mean, everybody knows me anyway, I think so.
Okay.
Yeah.
No. Well, I was expecting Phil to say something. So yeah. So I'll just really quickly say, yeah. So thanks so much for coming out to our very first E-Colloquium. So E-Colloquia are a great way for us to put on talks featuring high caliber and, in particular, mobility limited speakers at much less cost to them and to us. E-Colloquia also help to reduce the extremely profligate greenhouse gas emissions from air travel, which is morally imperative, especially in light of the new IPCC report, according to which we have 12 years within which to take drastic action to limit GHG emissions to prevent the extremely harmful effects of global temperature rise exceeding 1.5 degrees Celsius. It's been estimated actually that the greenhouse, up to a third of the carbon footprint of an institution like the U of A comes from air travel. So this is actually a really great way that we can cut down on that, and also have wonderful speakers like Adam, who we otherwise wouldn't be able to see. So with that, Phil, do you want to say anything about? We all know Adam. So Adam, we're very much looking forward to your talk. So thanks so much.
That's a lot of noise. That's nice. Okay. Yeah, so it's important to get this right so we can do it, or to learn from my mistakes so it can become a kind of a norm. Okay, so this is a talk sort of in the epistemology of mathematics. And there's something rather old-fashioned about it. The issues have been around forever and became very live in the 70s. Now they're of historical significance in that philosophy of mathematics has taken a mutation, which I only engage with at the very end. This is half of a projected project. I'm intending to write it up in the spring, all going well, into a really pretentious paper. So you can this is your chance to nip it in the bud. And I'm a terrible chess player, and the reason I'm a terrible chess player is that I've got all kinds of clever, ingenious, brilliant schemes, but completely ignore what the other person is up to. And the same goes sort of in philosophy. There may be good ideas, but there are certainly objections that I have any inkling of. At the bottom of this slide, there's the address for where these slides are on the web. So, and I repeat it at the end of the talk. So if you want to check up on them, that's where they are. I want to begin with something that looks as if it has nothing to do with the philosophy of mathematics. Oh, come on, you see this weirdos. Yeah. Okay, wait a second. There'll be a lot of this. I fear it's kind of. But that I don't know how it slid itself down. But there we go. With something that's really about perception rather than about thinking. When vision, to a first approximation, is a kind of a passive thing. The object you're seeing causes your visual impressions. I know in detail it's not like that, but the surface is like that. But contrast it with feeling. When you touch stuff, imagine you're touching something in the dark and trying to figure out what shape it is. One way you get a lot of information is by what you do. You move your hands and you make yourself have sensations. And so your information is partly what you what sensations you get when you move your hands, and partly what you can and can't do. You know, I can move it right, I move it left. I try moving it up, it gets blocked by something, so there must be something there. And you don't reason very much about it. You just get an impression of what shapes are there in the dark from that. And I think mathematics is a little bit like that in a way that might become clearer. And as a sort of a hint to that, psychologists of mathematics say that who concentrate more than they should on arithmetic rather than the rest of mathematics, say that neurologically it's connected with your brain regions for your fingers. Counting on one's fingers, it varies from culture to culture how you count on your fingers, but everybody does it one way or another with their fingers. And so there does seem to be some deep intrinsic connection there. And you can certainly count to six objects in the dark, and you can verify that 3 times 2 is 6. You know, divide them into three groups of 2. What? 1, 2, 3, 4, 5. I don't know what this thing is doing here. They look kind of like chromosomes, don't they? But you certainly by reaching around stuff you can count them, and you can rearrange them in ways that amount to counting or amount to arithmetic, and so that's just a very vague suggestive connection. But when I go slide down, okay, so it looks like the page up and down isn't doing that, and I have to do it kind of. So if I go page down, yeah, that's what we can do. Okay, so now here's my one paragraph summary, so you know what's happening. There is something like a causal connection between mathematical facts and human psychology. So, you know, Plato's heaven, our little minds, and we don't think there's going to be causal connection, but there's something very much like it. And the connection is that you get beliefs, you get stuff about, you have mathematical thoughts, and you wouldn't have been able to have those particular thoughts unless the mathematical facts were as they are. So if you think and you prove stuff and you run through your intuitions and you end up somewhere, you wouldn't have been able to do that unless the facts were what they are, if you're doing it correctly, if you're doing it well. So knowing what you've done can tell you what the facts are. And making a proof, for example, is an activity. So what proofs you can and can't make is like feeling in the dark. There are limitations to what you can and can't do, and those are produced by what's, you know, whether 3 + 2 = 6 or not. The same for all kinds of other more sophisticated things. Okay, so in this way, and we're going to try and get a little bit closer to it, there are causal theories of knowledge and of reference. I'm not going to talk about that in this half, for mathematics. Okay, you go home now. That's it. You got it. But at this point, you might think of vague outline worries and objections, put them in your head, and then when we discuss, the way I listen to a philosophical talk is at the very beginning, I get a sense of where the person is going, and I make objections, and then to my annoyance, the person has anticipated them. But that gives me something to hold on to at any rate. Okay, we got another slide. So throughout the history of the philosophy of mathematics, there's been this kind of quandary. Uh, uh, Proofs and things like that happen in little bits of the material world, namely our brains. But the facts, they're very abstract. Depending on what they are depends a little on your construal of mathematics, but they're not like tables and chairs at any rate. So how can the one get a grasp on the other? This in 1971, so this is practically prehistoric. Paul van Astraff wrote a very influential paper called Mathematical Truth, in which he has a footnote to me. And I can't remember ever talking about this with him. So I figure he was just being one of these nice people who refer to their students when they have a chance, because it might be useful for a job or something. But in it he says, and you got a quotation in red here, if you try and integrate mathematical and non-mathematical talk, which any really satisfactory philosophy, epistemology of mathematics or philosophy of language that applies to it should be applied to a whole range of our activities. Then, as this quote says, there's a kind of a focus problem. You either get truth in focus and then knowledge goes out of focus, or you get knowledge in focus and truth goes out of focus. There's he thought, some systematic reason that you can't get both in focus at the same time. It's kind of a Heisenbergian, if you want. And since, in a way, people have been, that's a nice formulation of something that, it's been in the atmosphere since Plato. And people have been sort of wrestling with that formulation ever since. And that's, although people don't much write about van Astraff's problem anymore, it's shaped the way that the subject has developed. So, proceed on. He was writing in the early days of the causal theory of knowledge, and people would just say stuff like, the facts are going to cause what you believe. But just a few years later, it got summed up in a formula by Robert Nozick, which went, it's the condition in which you know something is when, if it wasn't the case, you wouldn't believe it. So, you're watching something and it's moving. And the fact that you are actually tracking it, and these at that point were called tracking analyses, is that if it had been somewhere slightly different, your perception would have been slightly different. You can see that there's that counterfactual suggests a kind of causal relation. This one here, that's the way your beliefs are sensitive to the way things are, and there can be lots of mechanisms that make that sensitivity. It could be perception, it could be reasoning, but when one changes, the other change, and it's systematic. So if one had been different, the other would have been different. These are now typically called sensitivity rather than tracking. Partly, I'm not sure, because they want to be confusing. We're going to contrast that in a moment with something called safety. And since they both begin with S, you can't get nice little formulas for it. So out of nuisance, they call it sensitivity. Okay, but suppose we're interested in the philosophy of mathematics, in mathematical knowledge. And van Astraff was saying, well, look, there's a problem if you do things this way with a necessary truth. If you have too Platonic an idea of them, though I'm going to kind of doubt that. And the problem, there's a formal problem when P is when your proposition is necessary. You say, if not P. Well, when does not P happen? When does 2 times 3 not equal 6? Never. So you got an antecedent, a conditional with a necessarily false antecedent. And because it's necessarily false, even though it's a counterfactual, it comes out true. And that's even true when you don't believe it or anything. So you're in danger of getting trivial knowledge. It's not likely to discriminate anything. Now, beginning in the 1990s, so ages after the era we're talking about, sensitivity analyses of truth acquired a rival, which is much more popular among epistemologists. I mean, there are lots of little nitpicking, get-here type counterexamples to this formula, as you can imagine, and there are some things I'm going to say, but people are happier with the general lines of a different account, a variant account now, which is called safety rather than sensitivity. I, for years, found it much less, why is that not going to go down? Much less plausible, much less intuitive. Oh, come on. Okay. I think it just freezes and it comes back. Oh, so we want.
I think you went too far.
What's happening is I'm confusing page up and page down, and it's got a time delay. So here we go. Except I've gone up too far now. Okay, down one. That's it.
There you go.
I've just got to allow the time delay so that I click it, then I have to be patient and wait. So it's kind of the opposite. If you hadn't believed it, that would have been because it was false. It's not that you're not believing it would have made it false, but suppose that you're kind of accurate. So when you believe something, it's true. And epistemologists say that handles a priori truth is the stuff they're mostly interested in better. And it's true, it does handle it better. So you're thinking about something, and imagine variant situations where you hadn't formed that particular belief. Well, that would have been a situation where it's false, okay? So again, you're just looking at a scene, to take a perceptual case, and you've got a belief that things are as they are, so it's a true belief. But there's a connection between the facts and your belief, and the connection is that that if you hadn't formed that belief, if things had been different, so you hadn't formed that belief, they would be different in a way that means that belief would have been false. So you're only going to form that belief when it's, say, an appropriate belief. So you can see that that has attractions, and it's not the same as the former, even though they look like kind of contrapositives of each other, but they're counterfactuals, and counterfactuals don't contrapose. There are well-known examples for that, and I wrote one down in my notes just in case somebody challenged me on it. But again, there are some problems with, well, in fact, there are definite problems with when you've got necessary propositions, because again, since the 2 times 3 is never not 6, so what we say, the consequence is P would have been false. Well, that never happens. And the result of that is that the conditional is rarely true. But I think there is a solution, a fairly natural solution, which I'm going to tell you about in a second. I'm actually, you see, I've put some timing at the bottom of these slides on the assumption I'm going to last an hour, and we're slightly ahead of time, which is good. So Okay, come on. Oh, okay, so yeah, we go. Uh, uh, okay, so uh, the alternative is this. Uh, was it actually? Maybe it was on the previous slide. Uh, uh, yeah, the easy solution to that problem is not to say that if you hadn't believed it, it would have been false, but say that if you instead of believing it, you believe some alternative to it, and obviously it's going to be kind of delicate how you choose your alternatives. Then that alternative, if you believe something else, it would be because you would have believed some other truth. So you're reliable, you're accurate. When you believe things in this area, they're true. Uh, and so I'll give you the next slide does have some examples. Suppose you're good at arithmetic. Uh, believes, I say, because it's some person, she believes the square root of 169 is 13. She's wondering about square roots, and that's what she comes up with. Well, suppose she hadn't believed that, but suppose she is good at arithmetic. And so instead she could have believed that the cube root of 2,197 is 13. She gets bored with small squares. Or she could believe that the square root of 729 is 27. I went and checked all these. I can't do them in my head. So if someone is good at arithmetic and their conviction that the square root of 169 is 13 is knowledge, then if they're, although if we rerun history and they believe that in a slightly variant situation, they may not have that particular belief. They're going to have some other arithmetically true belief. So they don't, her thinking doesn't make her have false beliefs. It gives variant true beliefs. So there's this is my variant version of safety. Okay, or more sophisticated, mildly more sophisticated. You suppose you've proved, in the sense that you put together a string of symbols that's convinced you that the sum of two odd integers is an even integer. Like 7 plus 3 is 10. Well, again, you're playing around on a blackboard, and you might have proved something else. Well, if that's the kind of topic you're thinking about, you might instead have got to the conclusion the sum of two integers divisible by 5 is divisible by 5, as you probably noticed in grade 6, or that the product of two odd integers is an odd integer. So again, the same kinds of thinking is going to lead you to something true. Okay, none of this is terribly surprising. What's going to be surprising? Let's see, is this going to go down? Yeah. Is that this is quasi-causal. Why did it say time there? Well, I don't see that. That's heading's time seems to me quite irrelevant. So this just paraphrases what I've just been saying. There are alternatives, and if you hadn't believed this thing, you would have believed an alternative. And so the relevant alternatives are those that you could easily have entertained, those that you could have concluded, or which would have run through your mind with an air of plausibility on your way to that particular occasion, on that particular occasion. But sorry, that particular conclusion on that particular occasion, not given that you're being zapped with Z-rays by a maniac psychologist, but in the sort of variations in what was your actual situation that you were likely to find yourself in. So you wander into, you open up your notebook and you start musing about jotting down notes about some some topic that's occurred to you, and this is you, the real you in the real world, things that would actually likely to are like causal possibilities for you. And in that particular situation, having had the exact number of cups of coffee that you have had that morning, we're allowed to vary them a little. We get slightly varied situations. And you end up with other, mostly, other true beliefs, okay? I say mostly because all of these counterfactual accounts of knowledge seem to think that you don't know it unless you're always going to get a true belief in if there's a small variation in the situation. But that's a route to skepticism, I think. People make mistakes. They have the most brilliant mathematician makes mistakes when on times people with wearing their contact lenses under good illumination make visual mistakes, and you shouldn't say that nobody knows anything. It's something. The right corrective, which I'm not going to make, is that most of the time they're going to, under most variations, they're going to get true beliefs. The literature, the general epistemological literature, is beginning to recognize this, but it doesn't have a systematic way of doing it. I mean, most is not a terribly satisfactory. It has to be more than just most, 51%. There has to be some sort of measuring in here, but how to do that is not clear to anybody. Okay, so for reasons that probably we didn't get into, one of the alternatives to the thing you actually believe, one of the things you count as an alternative has to be that belief itself. So don't give me clever counterexamples based on ignoring that. My use of the terms is slightly unnatural because I'm counting something as an alternative to itself. But that's okay. So these are kind of like near-miss cases. And also, if you know something, then there are going to be slightly more remote situations in which you almost get it. If you get another belief that's just a smidgen off being true, they're going to be more remote, I hope, but still, that still tells that what you've got is at least very near to knowledge. I'll ignore that. Oh, I'm way ahead of time. That's good. That's good. We might have a lot of discussion. Here's I've been talking about proof, and I've said that my examples have been somebody sits down with a pad of paper and proves something, and we wonder, and suppose it's true, we wonder if it's knowledge. Well, we think what else she could have proved if in the same state of mind, but it doesn't really have to be proof, meaning you've got axioms and you deduce things from it. I mean, most mathematics isn't really like that. Maybe when you publish it, it's kind of like that. But even then, it doesn't look like a logician's idea of what a proof looks like. But a lot of what happens when people just think about mathematics is they play around with intuitive things. They have images in their head. They move their hands. I once read an account by a mathematician of what happens at a mathematics conference. And he says, well, there are these really very sophisticated results, and you meet somebody in the hallway and you say, what the hell is this all about? And that person then moves their hands around, dances a bit, and says some jokes. By the end of that, you got it. And Lord knows how it happens, but it does. That seems to me very plausible, mysterious as it is. So here's halfway between that sort of process and formal proof. We had an example: the sum of even numbers is even. Okay, so suppose someone was wondering, is that true? Tries a few examples. 8 plus 2 is 10. 6 plus 46 is 52. Yeah, this seems to hold for some examples. Is it always true? Suppose we get million-digit numbers. Is it going to work for them? It's million-digit prime numbers. Is it going to work for them? Oh, God knows. Can't think that one through. Then the following occurs to them. Take an even number. So that's going to be, it's going to have two stretches because it's going to be a double number, as it were, 1 to n, and then you're going to add 1 to n. Then another even number, 1 to m, 1 to m, and you rearrange it. I thought there must be an intuitive consideration here, so this is what I came up with. So you move that 1 to m down to that 1 to n. Yes, and that 1 to n up, that 1 to n up to the 1 to m. And then you've got two stretches of 1 to n followed by 1 to m. So you've got two stretches of the same number, right? And you've got two stretches of the same number. The total length is going to be even. So you've just rearranged. You haven't added or subtracted anything. So what you've got now is still even. Now, I'm sure you could turn that into a mathematical proof, and I'm sure that the words I used weren't perfectly transparent. But if that was you thinking about it, you would have you would have got the picture, and having got the picture, you'd have the conclusion. Like I said, that same sort of fooling around with a little series of numbers might have got you to a different conclusion. But if you're operating accurately, it would have led you to a true one. Okay, that's what the alternatives are. I've thrown in for equal measure something else that counts as mathematician would count as a proof, but a logician might not. Namely, just doing a little bit of algebra without any axioms, just sort of taking as what you've learned in school for doing it. So sum of odds is even. Well, you got one odd number, which is one more than an even number, and another odd number, which is even. So we rearrange them again. So you got two even numbers. These are going to be typically different ones. You add the two ones, you get two. So you got two evens. And we know the sum of evens is even now, right? So this is going to be even, and it's two more than an even number. So it's going to be even. So again, that's no point teaching you grade 9 mathematics, but it shows the kind of informal consideration which is continuous with the real mathematical thinking, and which you can see something's going through somebody's head, and there are lots of variations you could play on it. But if they're doing it right, if the result they get in the end is knowledge, doing it in those variant circumstances would give you a different truth. The other things you could get by rearranging rows of numbers and stuff. Okay, so there is something that's slightly contentious, or I suspect some people would disagree. Take a professional mathematician who gets drunk one night and playing around with symbols and stumbles on a correct proof of an important result. Okay, gets tenure a year later on the basis of this. But in that, take this mathematician that night, and under the influence of all this alcohol, the things that they would have been inclined to do would have ended up with fallacies, and he or she wouldn't even have noticed. Would say, "Oh yeah, that's neat," Um, uh, I should come up with a list of fallacies that could be neat conclusions you could form at that point, or falsities. But this, in that state of mind, this person wouldn't have seen as the conclusion as flawed, these alternative conclusions as flawed, even though what they did end up writing down, wrote on a blackboard, maybe on a notebook, was an absolutely correct proof of something true. And important, I'm saying, okay, profound. So next morning, can't remember anything, goes back to his notebook, sees it, looks at it and says, oh my God, that's really interesting. Publishes it and becomes famous perhaps. But go back to the night before, when tiny little variations would probably produce, somebody, if you left out a negation, or it was a greater than, less than rather than a greater than, you would say, oh yeah, that's neat. Be just as happy with it. Now, although he's got a valid proof of a true result, proof from axioms that everybody acknowledges, or something like that, that doesn't seem to me like knowledge, because I'm trying to integrate this picture of mathematical knowledge with a general epistemology, where it's kind of like a matter of reliability. It's a matter of in slightly variant circumstances, you would have got a true result just as like you did in these circumstances. So sometimes something's proven, but it's not known. So don't equate these two things. I mean, we all know now, as of last century's logic, that you mustn't equate truth and proof. But some people do say knowledge in mathematics is proof, is what's proven. Not truth, but knowledge. So a subset of what's known, a subset of what's true. But the picture I'm giving you breaks with that. It's when, and I haven't really wondered about it. Even proving it and knowing that what you've got is a proof probably is not going to be enough. It's going to depend on various this reliability business. Okay, we go off in lots of angles at this point. Well, I've already talked about. Even the most brilliant mathematicians are going to screw up sometimes, and we don't want that to disqualify it. So that's something not to get into. There are ways in which this makes a continuity between everyday perceptual knowledge and at least the kinds of basic mathematical knowledge I'm talking about, I've been using as examples, and scientific knowledge. They're all going to sort of have continuities between them. I think you're going to want to tune exactly how you define knowledge, what counts as an alternative, for example, what kinds of variant situations you're going to take account of. I suspect you won't get a simple, unless you keep it very schematic. I don't think you're going to get details that are going to bring all these things together. But there are going to be continuities between them. They won't look totally different. But I'm not going to try and make good that assertion right now. I also think it'd be nice not to phrase these things with then she believes something that's true. Conditionals that way. Be nice not to use the concept of belief or put such weight on it. And as you probably know, a big influential strand in contemporary epistemology is called knowledge first, and says to hell with the notion of belief, to hell with defining knowledge in terms of belief. It's our primitive concept. We sort of make gestures towards defining belief in terms of knowledge rather than the way around. other way around. But we don't think that's a real definition. That's just a gesture. We'd rather not talk about belief at all. Well, I'm not really a knowledge first person, but I do think de-emphasizing belief would be nice, partly because it's a kind of slippery concept. People think lots of stuff goes through their heads. What are really they believe? Well, it's in context that's often clear, but it's okay. Another thing I'm not going to talk about. I'm acting as if I'm under time constraint, but it's obvious that I'm more likely to stop and say, okay, let's have coffee now. There are links with the psychology of math here. So as a causal theory should, it's realist. There is at least a gesture towards realism here. I mentioned fingers, but the kinds of provings, the kinds of things that are not formal proofs, but are ways you convince yourself of something. I mean, that starts with geometry. It starts with Euclid in a way, and that's what you're doing is you're taking little diagrams, you're playing around with them, you're finding some manipulations of them convincing. So visual imagery is going like that. Kant talked about arithmetic as being in terms of the psychology of time perception. Well, certainly the intuitive grasp on it is like that. But we're in situations where when you trust yourself just to play around with the images and the intuitions in your mind, you end up with truth, which is not true in physics or bird watching or ornithology, but it does seem to be true in some areas, like shapes and areas, if you're talking about regions of the Earth which are approximately Euclidean. But that's an accident. What's systematic is that that's an area where if you play around with it, you stay within true belief. Somehow doing it just in your head seems to work, as it does in arithmetic. Okay, but in a way, it's an empirical fact that your patterns of reasoning are self-sufficient like that. But I'm not going to talk about that. I have talked about it, but I'm not going to. I mean, just now. Okay. Okay, so have I done my usual thing with the slides now? Come on. Okay. Okay, this is what I'm not going to discuss. I'm going to be patient and wait for that to come down. I think that's right. I should have more clearly numbered them if I knew it was going to behave like this. Okay, so we started with an image of looking, feeling things in the dark, right? And you know what shapes they are by what you can and can't do. Well, proving stuff, just thinking about stuff, making counterexamples, they're all mental acts. They're things you do, like getting your fingers around something. And also counting, gathering together, counting being, having a certain intuitive connection with arithmetic, gathering together, having a certain intuitive connection with set theory, rotating, having a certain intuitive connection with group theory. And they're all mental acts, and they're intuitive mental acts. And with all of them, if you're doing them in the way that becomes part of a mathematical tradition, and this may take some time to settle down between when people start thinking these ways and when it actually acquires a symbolism and a traditional formulation. It's so that the way when people operate within those parameters, they systematically end up with true beliefs. So when you do that, then and if you're, sorry, this long sentence began, if you're doing it correctly within the way that pattern of thinking has grown up, then you find there's some ways of conclusions you don't get to. And the ones you don't get to are typically wrong. And although it's not predictable what true one you're going to get to on a given occasion, it's going to be it's going to be constrained by the things, the ways the conclusion you don't get to. And the reason that's going to be constrained is that the facts, get facts about rotations if it's group theory or whatever, are going to be such that you won't get the harmony is developed between that pattern of thinking or intuiting or playing around with stuff and the way things are, that because the only way to explain why you'll never get this false result thinking that way is because that's the way cyclic groups work or something like that. You get the results you do because the mathematical facts are as they are. You get the intuitive results you do because the mathematical results are the way they are. So the facts shape the mathematical facts shape or constrain the mental acts, and so the mathematical value explains what's possible and impossible for the mental act, and that causes your belief, and which is what the safety analysis is all about. I mean, your act causes your belief. The proof you've done, or just the fooling around with little columns of figures or geometrical diagrams or whatever, that causes your belief, and the fact also explains why it's a true belief. It explains rather than causes it, but it explains why it's a true belief. So the causal bit is that what you can and can't do causes you to have this belief and not that belief, and it causes it partly because the mathematical facts, I keep on using this word, are as they are. The numbers, groups, sets, whatever you're talking about, are the way they are. And that's what allows, if you want, you're playing around in your mind to end up where it does and not end up where it doesn't. Okay, and that, I think, is, oops, okay. Oh, come on. Okay, I'm going to go up one more just to see that I haven't skipped one. No, I haven't. So what I think has happened is that I went down 2 a moment ago, but it's okay, it'll work. So as I was just saying, the explanation of why you would have arrived at a true conclusion uses the math. So try assuming that the mathematical fact is wrong, that the cube root of 2,197 is not 13, and then explaining why somebody's belief that it is 13 would have been true. You obviously can't do that. Ooh, what's going on there? So when you're trying to explain, I think there's a more interesting fact there, more interesting way of putting it. If you're trying to explain why reasoning in her her disciplined way she would have got to that conclusion, and if she got to another conclusion, it would have been another true one. You can't really explain how that happens. If you were, for example, denying that the arithmetic facts, just as you use arithmetic use a lot of mathematics in physics, you're going to use it in psychology. And in everyday psychology, it's going to be your grasp of how people think is going to completely fall to pieces unless you assume it. So the math being the way it is required for the patterns of your beliefs and belief changes to be the way they are. So it does play a role in the explanation of why you think as you do. In a way, that seems kind of obvious. And you can sum this up. You can say, if the cube roots of 2,197 were not 13, she would not have believed it. I put that in quotes because, in a way, it's a barely intelligible counterfactual with this impossible antecedent. But if you take that as meaning, you want to explain why she believes this, then you're going to bring in, you're going to have to use this fact, or facts are very much like it. Facts of that kind are going to play a role in explaining why she does believe what she doesn't believe this, or why she believes some alternative to this, a true alternative rather than this. And if you see this in terms of the facts constraining what she can and can't think, which is the feeling in the dark business, then if you take this thing in quotes as being summing up all that, well, given that background, it's not a crazy way of summing it up. Then you can see that it's intelligible and a reasonable thing to say. And so this is something like a causal account of knowledge for math. The mathematical facts are sort of causing. They're part of the causal picture that results in your having the beliefs about them that you do, which is what Ben-Asraf said he couldn't see his way to doing. This is my beloved thesis advisor, so it costs me something. I'm crying to see that he said something that anyway. Okay. Okay. Now I'm not going to remember that quotation from Ben-Asraf said you can bring knowledge into focus, but when you do so, truth goes out of focus. Now, when I write this up, there won't be this emphasis on Ben-Asraf because everybody say, "Oh, yeah, that's 40 years old." I'll stick in some more contemporary stuff, but it's a good way into the issues. And no way to get published, but it's a good way into the issues. However, when he said you can get a grasp of knowledge without, but when you do, truth goes out of focus. He meant pictures of knowledge of mathematical knowledge that focus on very concrete proofs. Formalism basically, then what you get just doesn't look. There's no reason to believe that it's knowledge. It's what people get. It's the things that you get a picture of mathematical doctrine, but not necessarily mathematical knowledge. So it's not knowledge in the sense that you don't have a reason to believe. Why is it going to be true? But my picture, the way I've been developing, is quite compatible with the Platonic or any other conception of what mathematical truth consists in. So there's reason to believe, but I'm just waving my hands at this point, that it is going to be compatible with a substantive picture of mathematical truth. But thinking that the two do have this complementarity, to use a Kuhnian phrase, an essential tension, has been very influential in that the subject is kind of split up into two sort of coexisting disciplines. There are people who work on the foundations of mathematics, and they're interested in proofs and formulations and how to put things in, how to reduce analysis to set theory or whatever you want, stuff like that. And then there are sort of like sociologists of mathematics. Many of them are in philosophy departments, but they'll work on what mathematical practice actually is. And so they're trying, both the people working on foundations are trying to create a rather artificial or rather reconstructed, rational reconstruction of mathematical knowledge, focused on the notion of proof. And the people working on mathematical practice are again trying to get an intrinsically mathematical ways of thinking that they're talking about. But they're not relating it to general epistemology, which relates to general views of truth, because they think that they've sort of absorbed the assumption that these things there is a tension between these things and you can't get them both in focus at the same time. But I'm hoping to break out of that, because I think you can make, just as you can have a picture of knowledge in this safety conception, which is schematic enough that it applies across a range of kinds of knowledge. So you can make so it's quite compatible with a Platonic account. It's also compatible with other accounts too. There just have to be some definite facts there, which we can have a reliable grasp of, such that if we hadn't ended up with that conclusion, we would end up with another true conclusion of the same kind. And that reliability has to depend on the facts being the way they are, however you conceptualize those facts. Just as, monster sentence, just as I'm assuming that, or I'm arguing for that, I claim, and this is the second half of the paper, which only exists in notes, you can make an equally all-purpose account of truth, basically the Tarski schema, but with an undefined reference relation. I mean, maybe satisfaction is left undefined. Unless your meta language is the same as your object language, which is kind of cheating. And that's perfectly compatible with what I've been saying. There's no but. Just as you can make a particular conception of mathematical ontology, you can make and mathematical knowledge and what the connection is, you can make this particular too. And you do that, one way of doing that at any rate is to fill in, I should leave the screen alone, stop.
So that's going down, I think you might go out.
Oh yeah, so thank you. You can see what's on my screen better than I can see it.
I can go straight from the RC to the conclusion.
Differentiating case. So I've got. So not only is he physically handicapped, he's blind. Okay, that's the problem. I don't mind being blind and immobile. as long as I'm not stupid. But there's some danger of that too. Okay, that's where we were. Okay, so I think you can fill in the reference relation in various ways, which are also quasi-causal, as just I was talking about knowledge being quasi-causal. And so I think, again, you get a schematic, vague general account of knowledge, a schematic, vague general account of truth, and they do fit together at that level. And then you can make either specialized, according to what your particular ideology of these things is, and the two ways you can make the two specialized in congruent terms. So this Banasarafian incompatibility doesn't actually exist, or it can be dissolved. That's my claim, but I haven't actually argued for that for you. What I've argued about is, and I think that's called conclusion, isn't it? Yes. See, we're there. Is that you can have a uniform knowledge, account of mathematical knowledge and knowledge of contingent stuff, and you've got responsiveness in both cases. So all this stuff is kind of standard to say. But what I'm claiming is it's irrelevant that there is no literal causal interaction with the objects. I'm not saying that there isn't, because I'm trying to be non-committal about what the objects are. What's important is that there be a fact that square roots of this or that e to the pi equals -1, and so on, whatever you want. So is there some phrase in the Tractatus where he says it's propositions that are important? The world is all that is the case, meaning it's facts. You break it down into particular kinds of objects. That's really kind of getting philosophical. That's interpretation. What the bedrock is that the facts are as they are. Well, so in however you do it, the facts are going to explain why your thinking works the way it does. And so the important thing that is quasi-causal, get this silly face out of there, is that the explanation of why the processes often, see, I'm saying often rather than always, result in true beliefs, meaning that if you had arrived at a suitable, most of the time if you've arrived at one of the alternatives, which I'm carefully not defining exactly what an alternative is in a particular circumstance, to the thing that you did end up believing, it would have been true, okay? That explanation depends on the objects. Well, maybe I shouldn't say objects, depends on the facts, depends on the mathematical facts, as much as it does on, what's going on, as much as it does on your brain chemistry or the your education mathematics or stuff like that. So there is a quasi-causal explanatory, here's what we have to say to give a picture of why it happens type account of why somebody is reliable, and to that extent why they have knowledge of a mathematical fact. Okay, that may sound kind of trivial, but I think you would have found that things follow from that many people would have denied. Okay, so if you want, we're now at the end. If you want the slides again, go to my website, my part of my website as opposed to Susanna's, and then you can follow it from there. But links from there will take you to this PowerPoint, which you've just been looking at. And I think there is no more. No, there ain't. Okay, thank you. I'm going to minimize this So I can see, maximize that. So now I can see you all.
I'll turn the volume up.
Yeah. Adam, we were wondering
Yes.
what the thing on your counter is. Is that like a prism or a hat?
Here's what it is. It's my daughter gave it to me. It's a globe in the face of in the form of a pyramid, and
Australia, right? Yeah.
and it's quite amazing. It's quite amazing that it's even possible to do that. And the continents come out roughly right. I think the oceans come out with distortions in them, but since there's nothing there, it doesn't really matter. Nothing except for your whales and things.
Yeah.
And a big garbage.
And the sea monsters. And the dragons.
Can't forget about the sea.
There's a lot more dragon territory.
Yeah, the dragons will be very distorted.
Yeah. Can I point out that saying that it's a globe, that's a triangle or a prism, is kind of contradictory? Just saying.
Well, look, there's an obvious what I should do. A second. One of the troubles with being in a wheelchair is carrying stuff around is tricky. So you saw me carrying a cup of tea just now, but that could easily be disastrous. Okay, so there's the camera. So look, you can even see Alberta probably, right? About there. And then, so look, there are these 1, 2, 3 faces, which are equal sizes. And then here's Antarctica, and I'm sure that's not accurate, that that's all of that area. But they squash things so that, well, Tierra del Fuego is down there in Antarctica, but there's North America, there's Eurasia. So it's kind of interesting. It's amazing that they all look familiar, you know? They all look like the shapes they ought to be. And I wouldn't have thought it was possible, but.
It looks a little bit like you have a map wrapping paper and you wrap some sort of, pyramidical Christmas present, right?
And most of the lines, most of the longitude lines are straight, except right by the equator, and except when they're in the middle of the ocean, when they have funny bends in them. So that's no doubt. And just now I'm looking at the circle, the Arctic Circle, and it's an ellipse. And it's not at the top apex. This is all the price you have to pay.
Yep. Well worth it, I would say.
Yeah, someone spent a lot of time trying to make, no doubt, trying various possibilities until it looked like it ought to look like.
Well, should we start?
Sure.
Yeah, I think we have to.
Yep. Well, that was really interesting, and you even actually made sensitivity and safety, which are terms that basically make me want to crawl into a fetal ball. Interesting. But anyway, my question might be a little bit off because I'm going to ask whether we might apply some of what you were saying to Hume.
Surprise. Yeah.
Surprise, it is, yeah. I didn't just choose any random early modern.
Yeah.
I mean, Hume, after all, not perhaps about knowledge, but of course has causal accounts of belief, right? So
Yeah.
it seems kind of appropriate to me. But I was wondering because so the account, his account of demonstrative knowledge, which would include what he knew of mathematics, is that it rests on so-called relations of ideas. And the claim is something like, can you hear me okay, by the way?
I can hear you fine.
Okay, yeah. Usually not a problem, but I thought I should ask.
It even sounds like you.
Oh, that's because I'm not using my outdoor voice. Yeah, so relations of ideas are like demonstrative reasoning rests on considerations of relations of ideas, where we can't vary the relations without varying the idea, while the ideas remain the same. So there's this, there's this, it's impossible to conceive. So in most accounts, I think, maybe not most, but many accounts would read Hume as reducing something like necessity to imaginative conceivability. But I'm wondering if your account might not work better for it. Because, the ideas that we have of, say, a triangle are, for Hume, are kind of triangular, or they have at least the relevant features of triangularity.
Like this.
Yes, exactly. And my idea of that would be, the intentional object, right? The idea is, copying the appropriate features of the intentional object. So I think this is nice because the thought is he could actually cover something like the necessary truth of demonstrations if it were the case that I could not. The reason why I cannot conceive of triangles and two right angles having some relationship other than they do is because they cannot have, because the mathematical facts are as they are, and they're just constraining the way I can, so to speak, move my ideas around. So that would mean he was not actually doing this kind of, sneaky move. Does that make sense to you, or am I?
When you started, I thought I was going to disagree because I thought you were going to. Because I thought I would have to say that he was making the triangles in your head be the triangles that you're talking about. Which is it's a lurking ambiguity in the word idea. And I was also going to say it was kind of like doing it all in terms of meanings of words, which again doesn't explain why it works in the world, for example, why you use this in physics. But then what you ended up saying is that you play around with this stuff in your mind, and it works. It gets you to true results. And part of the reason, an essential part of the true reason, is because that's the way it is. That's the way triangles are. The interior angles don't add up to more than 180 degrees. In fact, they always add up to exactly 180 degrees. Now, I don't remember Hume saying anything much like that, but it's a nice background. It kind of works. Probably for lots of other, as you say, early modern philosophers too. But it is slightly creative reading, isn't it?
Well, I don't know. There are some people who are reading Hume like John Marinetti is now trying to read Hume as a neutral monist. So what you've got are, perceptions, right? And the ambiguity between the object and, so to speak, it being the mental entity is built in there, right? It's intentional, and it seems like this is exactly the place where something like that would, could fit the causal picture. What I'm wondering now is, if that is, I'll use you maybe to raise a different kind of simple, perhaps, question. The trouble there is I think as you pointed out, is kind of the counterfactual, could not, so to speak, think of it otherwise, right? Now, when Hume thinks of matter-of-fact reasoning, causal reasoning, in some ways you can have the same story, right? The reason that I think of for Hume of such and such a thing being causally connected with other things is because, in my experience, they have been, right? They've shaped my mind in that way. But but of course there's a big difference there because I can actually manipulate those ideas separately.
Yeah.
That's why it's perfectly conceivable to think that causal connections don't hold. So I guess I'm wondering about how we would get, if this kind of picture is fitting what you're saying, how come the mathematical effects, so to speak, constrain in the way that they do, and how that's different from the way that the causal facts constrain in the way that they do. Maybe that's just outside of what you're talking about, but
No, but it's akin to it makes a link between something that people in other contexts get from Hume, namely the imaginative resistance, and you have trouble imagining some things, and it's typically things that are morally wrong for him. We'll imagine it. Well, never mind. I won't try and get it right. And it's hard to imagine. Well, we've developed ways of imagining the interior angles of a triangle adding up to more than 180 degrees, but people back then would have said it boggled their minds. And the explanation is not part of the proof. If somebody does a proof, it's because they're playing around with diagrams or deducing things from axioms. And that's just self-sufficient. But the reason why it counts as knowledge is a fact about that manipulation, which is that it does systematically result in truths without having to do your inductive stuff. But the explanation of why that is the case relies, like, to repeat myself, essentially on the fact that, at least in this domain, interior angles do add up to exactly 180. So there is a difference, and I don't think this is particularly Humean, though I'm speaking from ignorance, between the considerations that are working for the person doing the mathematics and the considerations that somebody else, like a philosopher, would use to explain why that's knowledge. Because, typically when there's another contemporary thing you don't know that you know. So you can do something and it results in your knowing something, knowing a mathematical fact, but that doesn't put you in a position really to establish that you do know it, though in fact you do know it. But that's where the reliance on the geometrical facts being as they are comes in. It doesn't come into the first order mathematical thinking. Is that okay? Enough? That's sort of semi-agreement with a number of glosses.
Yeah.
Yeah.
I mean, I'm just playing around, so
Yeah. Bernie. I see Bernie. Yes.
I like about your figure is that in the old days, they took the problem as somehow casting doubt on Platonism about mathematics. How can we possibly know these things? Whereas
Yes.
I think the conclusion of your argument is that we've got to work harder on our theory of mathematical knowledge. So suppose that we think
I'm having trouble, Bernie, I'm having trouble hearing you. Can you get near a microphone? Because I'm having trouble hearing.
Yeah, okay. So
use your outdoor voice, Bernie.
okay, yeah,
Sorry.
okay, so Adam, there might be a problem about whether there's 3 consecutive 7s in the decimal expansion of pi or something like that.
I remember that one. Yes.
And people might say, well, we don't know if there is or isn't. Maybe we should become intuitionists because we don't know that we can ever know this. I think your solution is that, well, there have been lots of things that we haven't known, and then we've discovered. Why do you think that the mathematical world isn't going to have these properties just because we don't have a good theory of knowledge to handle them.
Yeah, but the intuitionist view is sort of giving up on truth in a way. It's making it. It's got two moves, both of which are kind of dubious. One is identifying truth with knowledge, and they do that because they say, "My God, what can this stuff be except by what our conclusions about it are?" And then identifying knowledge with proof, right? But so identifying knowledge with proof without an antecedent conception of truth. But if you're going to have these reliability pictures, then truth is built into knowledge, because knowledge is beliefs such that if you vary them, you get more true beliefs. This, I mean, it's very funny that Brouwer was a topologist and was famous for very intuitive stuff, like fixed point theorems. So why he should be so hung up on proofs is kind of strange, but that's the way he was. And so I still miss something in the question, I think. Are you saying, yeah, that's it? I've got an answer to that, or that I'm kind of in line with that? I see. How does the connection with classic intuitionism go?
Well, that you have a response, and that you think
yes,
there are
yes,
cases where we have proofs of things.
yeah.
And that's a case where we know these are truths, and we have a pretty good idea of how we know them from the proofs.
Yes.
Why not
yes.
think that there may be other truths for which we don't have proofs?
Good. Yes, absolutely. Absolutely. And if that's the answer, I'm happy with it. And there was something else flitted through my head. And no, it may come back to me, but yes, all I've got now is agreement.
Yeah.
You've also got, here's what flitted through my head. You've also got a kind of an undermining of this conception of knowledge as proof. If you take it quite literally and you think somebody's produced a proof, well, they might have done it by accident. And if they'd had 2 cigarettes instead of 1 cigarette, they would have produced a fallacy. Now, I'm not going to call that knowledge,
And what about the mythical Indian mathematician who just sees the truths, right?
Yes. He knew a lot of them. Some of them were false, as it turned out, but yes. Ramanujan. I saw the film. I saw the film about him just a few months ago. I can't remember what it's called. The Man Who Knew Infinity. And a lot of it, Bertrand, you should see it because somebody is Bertrand Russell in that film.
I have seen it.
And one thing that's interesting about it is a lot of it happens in mathematics seminars in Cambridge. And what's on the blackboard actually makes sense as math. It's mostly analysis rather than logic, but instead of you see mathematicians in cartoons and the boards are covered either in unintelligible symbols or something that's basically just high school algebra. But in this case, it's right. They've actually, I don't know, they've taken pages out of Hardy or something, Anyway, that's all. Quite irrelevant to your question, but worth saying.
There's a way of knowing which doesn't involve proof.
Yes, there are many. And And if by proof you mean what proof theorists mean like proof, we prove almost no real mathematics is proved like that.
Yeah. Yeah.
So I guess
Howard.
there was something I thought you treated as more difficult than I think it is, or maybe is, and then there's something that I think might be a little harder than you take it to be. So first of all, when you were talking about worries about safety and kind of related worries, worries about sensitivity and related worries about safety that then motivated your relevant alternative kind of account. You were saying, hey, you know, all these counterfactuals with necessarily false antecedents, we can't really make sense of those. But at least recently, I thought everyone was now a fan of impossible worlds. And you just talk about what would be true in the impossible worlds where the necessarily false antecedent is true and things like that, which would allow you to make sense of both standard sensitivity and standard safety, right? So, you know, Chalmers has all this stuff, but, you know, there's a whole, you know, there's all sorts of stuff on the, you wanted to ask about the, I'm sorry, man, I'm sorry. Yeah, so, well, okay, so that's the first thing. Then I was also worried, though, about, well, just because you have these true counterfactuals with necessarily false antecedents, where we have your thing about what would be true with the relevantly similar you know, propositions, I'm not sure that's enough to justify causality, right? So like it being a genuinely causal theory of knowledge. So just because you have counterfactual dependence of this kind, it's, well, first of all, it certainly isn't like what Ned Hall calls production, like the Umfi causation kind of thing. But then also, in standard cases where we have counterfactual dependence, among just things in the, you know, billiard balls colliding into each other and things like that, we have kind of a picture of how it all reduces to the Umfi causal or productive web. Whereas here, it just doesn't seem that there's any sort of corresponding story about what these counterfactuals are doing. So I'm a little worried that just showing that there's the right kind of counterfactual dependence, I'm not even sure if we really understand how this counterfactual dependence works, and whether it's enough for causation. So sorry, that's a...
Yes, two questions. I'm not a fan of impossible worlds, and I am puzzled. I think there must be a lot to say, and a lot of it hasn't been said, about counterfactuals with impossible antecedents, or just antecedents that are very hard to see how they could obtain. So I think there is a problem there. I mean, I think there is a topic there, and it's not relevant to this paper, but I'm kind of interested in counterfactuals like if the North Star had been 2 degrees to the right, then I would never have got home last night. You know, my navigation would have been screwy. But the nearest, in terms of actual how things actually could have happened, the nearest possibility in which the North Star is not where it is must have diverged in the beginning of our galaxy, you know. So I probably almost certainly wouldn't, absolutely certainly wouldn't exist. So it's hard to discuss that coherently. One person's conception of causality on which it might turn out to be right, though he doesn't discuss these cases, is Judea Pearl has a picture of counterfactuals derived from his picture of causality. And I think you might get something local enough that you can just change the position of the North Star in my perceptual field without going back and rewriting the history of the galaxy. So all I mean is that there, as a response to your question, that's an evasion. But I think that there is a topic there. There is a topic there, and how important it is to handle that depends on your second question, namely, what is the role of counterfactuals in filling out the claim that it's a causal theory? And so switching onto that one, I think, well, views like these tracking views are sort of generally subsumed under causal theories, though you're right. We don't have a picture of a causal process, detailed causal process. And sometimes we think there's some supervenience and that somewhere down there, if only celestial intelligence understood how all the details worked, you would reduce it, but we're not going to. All you know is that there is some dependence. And if there is some dependence, and it comes from the way the world actually is, then I'm as satisfied with that as I would be with the causal theory. And even counterfactuals, well, it's possible. Well, okay. So even counterfactual connections between mathematical facts and people's beliefs are sometimes denied, though, as you say, if somebody believed in impossible worlds, I think putting together a safety type view wouldn't be so hard. It wouldn't be so difficult to get those counterfactuals to come out right. But still, to ramble on, still, it is informative to say, give a little detail about that happens, and say it partly consists in facts about your mental operation, but those facts are constrained by what the mathematics actually is. And that's surely an enlightening thing to say. The truth, the mathematical truth, does come into the story at some point, because if somehow you were constrained to deny it or ignore it, then you wouldn't get an explanation of why the person got these conclusions and didn't get those conclusions.
Yeah. No, thanks. So I agree with you that it's very plausible that the mathematical facts do constrain our beliefs in this way. Yeah. My worry is that we don't have any picture at all of how this works. So I wonder if Bannister would worry, like sort of you could call it a generalization of Bannister-App's worry, which is that we don't have anything like the explanatory story, the sort of fully causal in the ordinary sense explanatory story between physical facts and our beliefs about those facts, and how physical facts constrain our beliefs about those facts. We don't have anything like that story of how it works in the mathematical case.
Go on.
We have this plausibility sense that it must work, but we just have no account of how it works. So the analogy to the causal account in the physical case is just fundamentally dissatisfactory.
That's really helpful. But my response is to deny it, something you're saying, but it would be really nice if I got explicit about that. That's good. What I deny is that we have no account. I deny that we have no account of how the facts, the mathematical facts, come into an explanation of how our belief formation works. Like suppose somebody's playing around with diagrams, doing plane geometry, and they're making triangles and measuring them. Well, one measurement they're not going to get is that the interior angles of a triangle adds up to more than 180 degrees, and we can explain that by making a diagram ourselves, putting in the size of the angles, and then adding them up. And it follows from Euclid that they're going to add up to 180 degrees. So we kind of do have an explanation. It's not a causal explanation, but it's one that's sort of it's operating in the causal explanation the same way calculus operates in physics. Say, you know, you need it there. You need it there to make it work. So in a way, the answer is too easy to satisfy some people. It's like, it just flashes through my mind. It's like the answer to why is there something rather than nothing, which runs, well, take 2 rabbits, soon you'll have 8 rabbits, and then that's something, isn't it? So that's an explanation of why there's something rather than nothing, which I think is a perfectly good explanation, but Heideggerians are going to accuse you of idiocy if you just say that to them as the answer. And
all the Heideggerian. I mean, the worry is, you know, there didn't seem to be the story of why this constrains this, right, in the story about the triangle, in a way that's as robust as the story about how the physical facts impact on our sensory apparatus, you know, in the physical case, right?
Oh well, I just have to take 4 times as long saying it, I think, but this does connect with your with your counterfactual questions. I mean, the obvious way to explain that constraint in a more physical case is to say, you know, if the fly hadn't been this part of the area, then there wouldn't be this this fixation on this part of the visual field, and you know, do it kind of causally like that. But it's not really a helpful way to begin to say if 2 times 3 had been 7, then this wouldn't have been the answer. Instead, you have to say, why do you get this answer? Because you're counting your fingers, and there are 3 groups of 2 fingers, and let's see, look, you're going to get 6 fingers. It sounds a bit like a Wittgensteinian dissolution rather than an analysis, but I think it's real psychology. The reason why you end up with 6 fingers that way is that here are the fingers, and you've done it, and see, 1, 2, 3, 4, 5, 6, but that's all. No more answer on that question. Chris was going to say something, I think. No?
Oh, yeah. So your argument that having proved isn't the same thing as knowing something, I'm not sure about that, because it seems like your example is analogous to like perceptual cases where you actually have knowledge. So take a scenario like, say I'm at home, I can't find my gloves. And so I figured that I probably left them there. Something that I would, you know, very likely do. And then I just happened to look out the front window and notice the gloves lying on the sidewalk.
Yeah.
So I mean, in that case, right? It's really unlikely that I would actually have the belief that my gloves are on the sidewalk. Because
yes.
It's not likely that I would look out the window, right? But once I do actually look out the window, and once I can use that perceptual process, then I have knowledge. It seems like it's going to be the same thing with mathematical proofs. Like, it might be really, really unlikely you would ever end up in a state of mind where you could actually run through the proof. But once you are able to do that, it seems like then you know the
answer. I think I'm sure I'm going to have to think about this, because it's certainly true that a lot of our knowledge is accidental, in the sense that it's an accident that you happen to be thinking about this or be doing this thing that results in you having the belief at all. So there are. So I'm shaped by a classic Nozickian view. And it's less of a problem there, because if the facts hadn't been that way, if the gloves hadn't been there, you wouldn't have thought they were out through the window, because you weren't hallucinating or believing lies about believing somebody's unreliable but accidentally truth testimony or something. So let's stick with that for just a second, inadequate as it is for the mathematical case. If suppose that it's a situation, we want to say that we're not excluding cases where you're operating in good proof mode, but end up with a different. Yeah, okay. Here's my answer. Go back. Ignore the last three things I said. I was emphasizing alternatives. So you do know it if the things that you could have arrived at. So just as looking at seeing your gloves out the window, although it was a kind of an accident that you did form this true belief that your gloves were there, it's an accident even though it was knowledge. The way it was knowledge was that if instead you'd looked out the other window and seen the cat sneaking out to chase the squirrels, that would have been true too. So your perception was generally reliable, though it is kind of an accident that it got the object it did. So on my picture, I think this is going to work. The fact that this drunken person didn't know it, although they had a good proof, is not just that it was a kind of a drunken accident that they got a proof at all. It's that it's not just that it was a drunken accident that they proved that particular thing. It's that they could easily have proved something else. Written down something else, which could have been completely fallacious, and they would believe that just as well. So the same process could have led them to falsity equally easily, just as if you hallucinate where your gloves are, but actually they are there, then you could just as easily, it would only take another tick of your neurons and you would hallucinate something entirely different, which wasn't true. That's the analogy that I'm heading for.
So then you're drawing the distinction between like having the proof and then recognizing that it's a proof.
Sort of I am, I think. But I don't think, because, as I'm sure you do too, I want to keep a line between knowing and knowing that you know. I don't want to say that it's a proof only when you can recognize it as a proof or know there's a proof. Sometimes you just prove it, like people do arithmetic and they get right answers, but they're not going to give a philosophy of arithmetic to back up their answers. But it has to be. It's kind of delicate. I mean, you don't want to talk about too quickly about non-accidental belief, non-accidentally true belief, without lots of footnotes and marks of caution, because often it isn't entirely a matter of accident. You get that particular true belief, and your example will do, and there are millions of them. But it's going to have to be, I don't know how to put it, except in terms of alternatives. If you're not going to, I do think putting it in terms of of bare Nozikian tracking is too weak, and in other cases too strong. So certainly in some, the fact that the person would have recognized the sober person, the person in the morning comes down and looks at their notebook and says, "Oh my God, that's really interesting. How the hell did I come up with that? Can't even remember writing that." But that's, you know, that'll make my name. That's famous stuff. That person, the morning person, is different because they do have the conception of a good proof, and they are convinced by. So either they've got the rules of a good proof and can say this qualifies, or weaker and probably more, they get convinced by reading through it, and their conviction, they wouldn't have got, and that same capacity for conviction would have convinced them of other things if the writing in the notebook had been different, but only of the good ones, not the bad ones. Whereas the drunken person would have been kind of random, which of them was producing conviction.
So it'd be like sort of like analogous to like the really weak student in competition, and they actually get it right and they get the right answer, but I mean the chance that they would actually have done the procedure right.
Yes.
Really small, and they still would have. I mean, if they'd come up with, 27 divided by 9 is 8, they would have believed that.
Yes. And to digress the way I often do when people are asking sharp questions I don't have sharp answers to. Using a guy who's drunk is not really a good idea, because mathematicians take lots of substances, much stronger than coffee. Tarski took a lot of cocaine and so on, and so the getting your head in a strange space in order to push your brain really hard as some of this stuff needs is pretty common among mathematicians, actually. But getting drunk, well, all it can do is maybe make you write down some stuff that you later approach in a colder frame of mind and see if you can make something out of it. Same goes in philosophy, actually, too. There are bullshit sessions which are useful, and there's arguments. There are occasions like this which are different and serious, but you need both of them. But are you? Am I kind of satisfying you, Chris? Is this work?
Yeah. No. That's clear.
Yeah. Okay. But one thing is, that does show to me. That is an easy. That shows me some of the advantages of talking in terms of alternatives. I think it handles. It allows you to finesse the fact that you want to talk about a non-accidentally true belief while admitting that it is an accident which true belief you get. It allows you a way of feeling your way around that. I'm hoping.
Do we have any further questions?
Did you want to follow up about impossible?
No, you totally stole my question. That's why I always try to get it out.
I'm giving a book launch tomorrow night at this place where I live, and although the residents here are generally well educated, the largest single cohort is retired female doctors. I'm kind of afraid that they won't have met that many questions. So I planted the audience with some people with lists of questions they can ask if the audience dries up. So maybe seminar should be the same, but. Thank you for all that. I'll write down some notes now. As well, so it's one of those useful discussions.
Maybe we just, I don't know if we want to do just a little informal chatting afterwards. I was just going to mention, if that would be okay. So are you familiar with like Peter Lipton's work saying something kind of similar to what you said, or Sarah McGrath saying something similar to what you said?
The Peter Lipton work, if it's very similar, no. I know Peter Lipton on contrastive explanation. That's mine. That's my.
It's really interesting because the way you were talking about mathematical facts playing a role in explaining our beliefs, it's very similar to something that is in this paper, 2014 paper by Sarah McGrath called "Relax, Don't Do It: Why Moral Realism Won't Come Cheap," where she's attacking the analogy that some authors like Parfit have tried to draw between moral realism and mathematical realism. And they say, oh, well, we don't have to worry about the whole Harman explanatory challenge to our beliefs because, we just say whatever they say in mathematics. And Sarah McGrath is arguing that actually there's a really good case that mathematical facts explain our mathematical beliefs, for which there's no parallel in morality, about moral facts explaining our moral beliefs. And so it's, I could send it to you if you like, but, so she's got Peter Lipton.
Yeah, please do. I'd like that. That'd be really useful.
Yeah,
and I was wondering whether, in fact, there was a parallel the other direction, but I couldn't make it work, whereby the fact that something was a terrible thing to do would partly explain why people think it's a terrible thing to do.
So Sarah McGrath, I'll send you the Sarah McGrath paper.
Yeah.
So the whole problem is that it doesn't seem to be as convincing as a moral case. That's Gilbert Harman's old 1977 argument against robust moral realism. That it seems like to explain the best explanation of our moral beliefs is just going to be our psychology, our socialization, whatever. You don't.
Evolutionary history.
Exactly. All that too.
That would be a way in which you might think the facts would play.
Well, there'll be facts about what we did, right, to each other historically. But that those were wrongful ways of acting won't play any additional explanatory role. Right.
That's the crucial thing. The fact that our psychology does come into it is not going to push the conclusion. What's going to be relevant is that it's being an awful thing to do doesn't play a role, right? Exactly. And that
unlike Sarah McGrath, drawing on Peter Lipton, is arguing certain mathematical facts do seem to be part of the best explanation over and above just the psychological factors.
What I'm saying is that it's not that.
Sorry?
It's not that obvious to me that it's being a terrible thing to do. Doesn't constrain the explanation. But so that's the thing that needs attention.
It's inflicting enormous suffering. So why do you need the fact that that's terrible? What additional explanatory power do you get off of it's being a terrible thing to inflict enormous suffering over and above just the infliction of enormous suffering?
Well, maybe the fact that it's a repugnant thing to do is partly what makes people on reflection hesitate to arrive at that conclusion. I don't know.
It's a big thing in metaethics. I mean, the main thing I just wanted to give you was the positive case in the mathematical case, which McGrath and I and many others in metaethics find very convincing, unlike the way in relation to how we don't find convincing the sort of idea that the moral facts, independent of any reduction of them to other kinds of facts, plays an explanatory role in that. I'll send you.
Please do, yeah.
Can I just ask Claire, are we keeping you beyond your schedule?
You do what you need to do.
Sorry.
You do what you need to do on here. Okay.
Well, thank you for setting this up, Claire.
Yeah. Oh, yeah, thanks, Claire. Yeah, we really appreciate it. So by the way, your graffiti is still up in the department. We're looking right at your list of emotions over here.
Good.
Yeah. Can we show?
The university didn't manage to destroy them.
No one's managed to destroy them yet. Yeah, so I don't know if you can see your list of emotions there, and your Descartes posters, your Descartes versus Simon poster is still up by where your office used to be.
You know, there was one poster that the university came to and tried to take down, and all the graduate students came out of their offices and said, "You can't do this." And one said, "Oh, I got asthma. I'll have a seizure if you put any chemicals on this wall." But anyway,
that part of the story, that's great.
Wait, what was it that I didn't hear the last part either? What was it that what did they object to?
one graduate student needed a reason why they couldn't use chemicals to take this unglue this poster from the wall, and said, "No, my medical condition won't allow it."
That's excellent. That's excellent. So, yeah.
So we could send you. I was gonna say we could send you